All right, now let's talk about the examples that we're gonna apply Breusch-Pagan test and White test. We're gonna start with the Breusch-Pagan test using FS statistic. Remember, we have four versions: Breusch-Pagan FLM, White FLM, right? So the first one, Breusch-Pagan test using FS statistic. What is the equation that we're looking into? We're going back to our housing problem, that we were trying to predict the price of a house by looking at lot size, square feet, number of bedrooms, and etc. On the left, I have a model that I know for a fact is homoskedastic. Well, we're going to discuss it, but I'm regressing price on lot size, square feet, and bedroom. On the right, I'm going to work with a transformed version of this model. Instead of price, I'm going to work with log price. Instead of lot size, I'm going to work with log lot size. Instead of square feet, I'm going to work with log square feet. Well, the bedrooms, I'm going to use bedroom because bedroom is going to be 5, 6, 7. If I use a log bedroom, it's not going to help a ton. The distribution is going to be basically the same. Okay. So let me give you a hint. I hope that this transformation is going to fix the heteroskedasticity for me. So I hope that here on the right-hand side, we're talking about a homoskedastic model. On the left-hand side, we're talking about a heteroskedastic model, right? So this is our prior belief. Let's use the BP test and see if we can confirm this idea that the model on the left is heteroskedastic, the model on the right is homoskedastic, right? So as I'm going over through the code, I want you to remember these steps. Step number 1, estimate the model. Step number 2, just regress U hat squared on linear function of x. Step number 3, either use F or LMS statistic. So let's do that. Step number 1, regress the model. So let's say I run the regression, I call it MRM. This is my step number 1. Step number 2, construct your U hat. You see, there's this U hat. U hat is equal to residual of MRM, right? That's simple. If you do resid MRM, you're going to get the U hats. Number 3, regress U hat squared. Look at that. I'm looking at the summary of regression U hat squared on what? On all the x's. Lot size, square feet, bedroom. That's it. And then look at the p-value for the overall significance. This is the FS statistic for overall significance. It's 5. I don't know how can I interpret that 5. Is it big enough? So I will quickly look at the p-value. Look at the p-value. P-value is small. If it is small, it's good news or bad news? Bad news, because we reject the null. What was null? Homoskedasticity. So we reject the homoskedasticity. It means that on the left we have heteroskedasticity. Is that clear? Guys, what is this test? It's the overall significance test. I'm testing if this one, let's call it beta 1 is equal to beta 2 is equal to beta 3. Well, here we call them deltas, right? Because this is a regression U hat on those things. Let's say delta 1, delta 2, delta 3 is equal to 0. How do we test that? Overall significance. This is going to be one of the outputs in the summary, right? So left-hand side heteroskedastic. Let's do exactly the same steps on the right-hand side. Step number 1, do this regression. Call it MRM. We call it MRM underscore log to make sure that we distinguish them. Step number 2, save the residual. Call it U hat. Again, we call it U hat log to just distinguish it from the other one. Step number 3, run that regression. U hat log squared on all your x's. Quickly look at the p-value. Your job is to this, just run this line, look at the p-value, and if p-value is large, now p-value is large. We failed to reject. Good news or bad news? Good news. Because we failed to reject the homoskedasticity. So the model on the right is going to be homoskedastic. So it is matching with our prior belief that if I use the log transformation, it's going to help me handling the heteroskedasticity. We don't have the luxury of doing this all the time, because if your left-hand side variable or any of them that you're taking log is a negative number, you cannot do that. You can only take logs from the positive numbers, positive random variables. Right? So that was our first version. Let me use another color. This is number 1, Breusch-Pagan F. Let's look at white F. Okay. So how do we do white tests? Again, going back to the slide, these are the steps. First, run the simple regression, call it MRM, then save the residual, then regress U hat squared on, now use it more flexible form of X. It's not only X1, X2, X3, it's going to be X1, X2, X3, and quadratic versions and interaction terms, and then look at the FS statistics and LM statistics. So let's do that. Again, step number one, we're going to use exactly the same model. So ex ante, I know that the one on the left is going to be heteroskedastic, the one on the right is going to be homoskedastic, right? Okay, so we call it white test using FS statistic. Again, step number one, on your simple regression, call it MRM. Step number two, save these residuals. Let's save them, call it U hat. Step number three, so here's the difference. So we're going to use the alternative version of white test. Basically, we're going to use this one. What is y hat? Y hats are the predictions, right? So I'm going to say use the predict function. The predictions of these models, we call them y hats, right? So let's save them. So let's save those predictions, call it y hat, and then regress U hat squared on y hat and y hat squared, right? So this is how we do that, and then quickly look at the FS statistic, the p-value, small, again, reject the homoskedasticity. Bad news. Exactly the same story here. Let's do it one more time. So number one, regress your model, call it maybe MRM underscore log because this is a log version. Number two, save the residual. Number three, maybe save those predictions because these are your y hats. I call it log y hat. And then finally regress that U hat squared on y hat and y hat squared, right? Look at the p-value, it's large. Again, here's good news because we failed to reject the null, and null was homoskedasticity. If you compare these two slides, you know, the solutions, your conclusion is exactly the same. Either you use white test, FS statistic, or Breusch-Pagan test, FS statistic, right? And the last slide, we're gonna do both BP, so this is number 4, and white, number 3 and number 4, using LM ratio, okay? So this is the author of the package, and by the way, we're gonna use the package that we use for BP tests. It's called the LM test. In our face-to-face class, I'm gonna go over that package. So we have to install it first, and then call the library, and then you can use this function, BP test, right? So the author of the package decided to put some default values in the function, BP function. Now that if you simply write BP test MRM, automatically by default it's going to use the LM statistic version of the BP test. So this is what I was telling you that at the beginning of the class, that when it comes to application, it's as simple as this. And again, you can do it this way or this way, but for your final project, you can just simply run this one and be done with it, right? In the homework though, I want you to, I'm sorry, there's some delay here. Why it's not, give me a second. Sorry, I don't know why my computer got confused. But I was saying that, so if you simply do BP test MRM, so it's by default, it's going to be using the BP test, Breusch-Pagan test, and the LM statistic. Then you can simply quickly read the p-value. Look at that, p-value is small. So you reject the null, reject the homoskedasticity. So we have heteroskedasticity on the left, we have homoskedasticity on the right, right? And the same story here. So let's do BP test for the MRM log model. Let's quickly look at the p-value. Again, it's large. What does it mean? It means that we failed to reject the null, which is homoskedasticity. So again, good news, bad news. So the last thing is, so this was number 3, this is number 4. The last version is that if you want to do white test using LM statistic, right? So surprisingly, we can still use BP test function. I know BP, you think that BP is going to only be used for BP test, but we can use the function from the package, but change it a little bit. It's going to change from the BP test to the white test. And basically, we are regressing our U hat squared. By default, if you don't write this U hat squared, again, it's a little strange, but the author of the package decided to do it that way. If you just leave it blank, automatically it realizes that you're using U hat squared. And you're regressing it y hat squared. This is what we have seen before. Again, nothing new. And then, so if you do BP test, MRM pass the functional form that you want to do, it's going to be white test. Look at the p-value, small, bad news. Look at the p-value, large, good news. Okay, so what is the takeaway? If you feel a little overwhelmed and why we have so many different versions of that, here's the takeaway that I want you to remember. Okay, we are here. This chapter, in terms of application, cannot be easier than that. Run your regression model, whatever it is. Imagine your regression is wage, beta 0 plus beta 1 education plus you. Use the data and just save it as MRM, multiple regression. This is R code, right? So LM, wage on education, and whatever the data set is, let's say it's wage 2, but whatever. Then, as simple as this is the entire chapter 8. BP, MRM, that's it. Look at the p-value. If p-value is small, what does it mean? We reject the null. Reject the null, go to this path. If p-value is large, you fail to reject the null, go to this path. That's it. This is a takeaway from the entire chapter 8. All right, so in this class, we talked about what is heteroskedasticity, and we saw what are the consequences of heteroskedasticity, and then we talked about the consequences, and we said that, okay, it's a bad thing, so we have to, first of all, diagnose it. So how do we diagnose it? This is what we covered in this class. In next class, we will see how we can fix it. Basically, we're going to talk about these remedies. So this is a topic for class 25. Now that I know that my model is suffering from heteroskedasticity, what can I do about it? All right. See you in the next class.